Hello, everybody. So now we will talk about the cases that we will cover in this chapter regarding the unsteady state molecular diffusion. And we will have two different cases. One is the unsteady state molecular diffusion in a semi-infinite medium, and the unsteady state molecular diffusion into a finite medium. We will have an analytical solution to this case, and in this case will not have an analytical solution, but we will see some charts that we can use to get the solution for some cases. So let's talk first about the first case, which is the semi-infinite medium. But before we talk about the solution of these kind of systems, we need to understand first what we mean by the word semi-infinite medium. To understand this, let's consider these two cases where this person is swimming, and he is swimming, of course he's swimming at the surface of the water, and in these two cases he is swimming in water with different depths. So in the first case he is swimming in water with depth of 4 meters, and let's say he is 2 meters tall, so this is almost double his length. So 4 meters is not very deep. If he dives, he can go down and touch the floor or the surface of the swimming pool, and he can see what is on the bottom or on the floor. He can feel it. He can understand what's taking place here. So for him, this is a finite medium. He can feel, understand, and reach the other part. The same person can swim in water with very deep in a very deep water. And in this case, for him, he is still swimming. He's doing the same thing, but the depth is very, very far away from him, and it's still a finite depth. But for him, it's very far. No matter how deep he dives, he's not gonna reach this other side or the floor of the swimming pool. No matter what's there, he cannot see it, he cannot feel it, he cannot understand what's going on the other side. And that's why it's in actually, or in reality, it's a finite depth. But for him, he feels that it's infinite. It's farther than what he can reach or what he can feel, what he can understand. So this is, for him, is considered as a semi-infinite depth. So it's not infinite, but regarding the process that's taking place here, which is this person swimming here, for him it is a semi-infinite depth. So this is what we mean by semi-infinite medium in unsteady state molecular diffusion. So in this case, we have a surface where the diffusion is taking place from, or starting from, and the diffusion is going to take place in a very short distance compared to the dimension of the body or the length of this body. So for for this species that's diffusing, it's gonna go for some depth, and it's not gonna change anything on the other side of the body where diffusion is taking place. You can think of this like these two cases. If you have oxygen that is diffusing in water, so it's diffusing in the top surface of water and it's not reaching the other side. It is like doping of phosphorus in silicon wafer. Sometimes you dope, and this is a problem that we will solve. If you dope sulfur or phosphorus in silicon, despite having the silicon not very thick, but the diffusion is taking place in a very, very thin layer on the surface. So that's why it's considered as a semi-infinite medium. The case that we will deal with mathematically is the case where we have constant concentration at the surface. So the concentration here is constant, and the concentration in the bulk is always constant. So these are the boundary conditions. The concentration in the infinite part of the body is always constant as Ca node, and the concentration on the surface is constant as Cas. And that in the very beginning, before the diffusion starts, the concentration everywhere was Ca node. So these are the conditions that we have, or the boundary conditions that we have, boundary and initial conditions that we have, that we can use to solve the problem. And this is a point that is important to keep in mind, is that the boundary conditions affect the solution in a very, very great way. If you have the same equation with different boundary conditions, you might not be able to solve the equation the same way you solve it with the initial or the first boundary conditions that you have. And that's why this is something that we will play with in the mathematical manipulation of this problem, which is making sure that the boundary conditions are in a shape that is easy for us to deal with. And this is what we're gonna see in the next video, inshallah. So I'll see you then.